Okay, so this is the 8.1 homework. I'm not going to do the whole thing. I do want to do parts of it where there's a little bit of math or stuff. I mean, it's pretty much similar to what we just did in the workbook. Choose the best description and example of the null hypothesis. Well, I can tell you right now, null hypothesis has to have an equal sign. So this can't be the answer. So it has to be one of these three. Read through this and go back and read the definition of that. So once again, I'm not going to do it all for you. I wanted to get to the math portion of this. But that's type of questions. There's some definitions at first, the type of questions that are on here. Type 1 error occurs when, so read that, and those are the boxes. More definitions. More definitions. We'll get to it. Okay, so in this one, it says use the Z table, but use your calculator. Find a critical value for a right-tailed test. So as soon as you see right-tailed test, you shade in the right side with an alpha of 0.04. So we have to find the critical value, the Z value for 0.04. In order to get second vars on our calculator, number 3, you have to type in the area to the left of the Z value. And if 4% is to the right, 0.96 is to the left, 96%. So you have to use 0.96 on this to get the actual Z value. If you use 4%, you're going to get the negative version. You can use that and then just change the sign. Second vars, number 3, 0.96. And I get a Z value of, and round it to 2 decimal places, 1.75. So that's not too bad. All right, let's try to see what's next. I mean, this one says two-tailed test. So I like to do the two-tailed test also. Two-tailed test means the right side and the left side are shaded in, and our alpha is 0.08, so half of that is 0.04 and 0.04. The total has to be 0.08 shaded in, and you got to cut it in two. Second vars, number 3. Second vars, number 3, and if you type in 0.04, you get negative 1.75. And since it's symmetrical, you're going to get a positive 1.75 here. And it says round to 2 decimal places and separate by a comma, negative 1.75, comma 1.75. Those are our critical values. Okay. Let's see what else we have. Okay, this is kind of cool. Well, it's not kind of cool. We have to fill this in. Remember, there are only 3 possibilities. Our HO, the average equals, and H1, the average does not equal. HO, the average equals. HO, the average is greater. HO, the average equals. HO, the average is less than. There's only 3 possibilities to write down in your HO and H1. I know this is going to be our average equals. And in this case, we're dealing with 24.6. See the average, state the null and alternative. The average Daily Community College is less than 24.6. As soon as you see the word less than, that's our alternative, less than 24.6, because the null is always equal to. The scientist is trying to prove that it's less than. So that's all you have to do. It's one of these three that have to be written down. You can't write anything else down. You can't write the average for the HO. You can't write is not equal to. It HO, if you look, has to be equals every single time. Then you have to decide if it's not equal, greater than, or less than. So only three possibilities for our HO and H1. Now, this is a little different. I would write these down right here, is at most, because it's a little tricky there. And I'm hoping the example shows us this. When a claim is stated at least or at most, the statement implies greater than or less than and equal to. So, and we can never use those symbols, greater than or less than symbol. So in the case of average, at least, yeah, there we go. In the case of average, at least, the average is less than least. That will be the H1. If you say at most, then the average will be greater than 25.4. At least, and then at most. So those are two other ones to know. The words. So at least your H1 is going to be less than. At most, your H1 is going to be greater than. So that's a good one. And I don't know how to get out of here now. Let's see if I can figure out how to get out of. Oh, I think I just hit X. There we go. Okay, so let's look at this one. This is kind of, this is the same thing. We know it's going to be equals, right? The null is always equals. And the only number I see is 70. For the following conjecture, state the null and alternative. The average resting pulse rate for a male runner is 70. It equals 70. So we need to figure out, do we put not equals, greater than, or less than for the alternative? Well, it doesn't say greater than or less than in the statement. If you read, it's is 70. The only alternative to is 70 when there's no greater than or less than in our statement, the only alternative is not 70. Do you see? So for the following conjecture, state the null, it says male runner is 70 heartbeats. That's kind of hard for every marathon runner to have exactly 70. You can have greater than or less than. Another way of writing that is not equal to. Since it doesn't say greater than or less than, we just say it's not equal to. The alternative is not equal to. We know the null is always going to be equal. The alternative here, since they didn't say less than or greater than or at most or at least, we write down not equals. And I think that's all I wanted to do. Let's see what 11 is. Here, once again, the average is 4.71. But they're trying to prove that the average experience in season for an NBA player has increased. Increased is greater than, right? More than something is greater than. And that is the homework section.